Hey guys, welcome to another video. So today, another video in the nice question series. Today's question comes from the advanced syllabus in the calculus optimization topic. So before I begin, if you haven't already done so, please subscribe to the channel, like the video, and tell your friends. Let's get started. So today's question comes from Sydney Grammar back in 2018. And this question, I don't know whether Sydney Grammar was the first place I saw it, but it's certainly been recycled or cycled through, used again by a number of schools. It's the classic question where you basically fold a sheet of paper, right, rectangular paper, to get, and then we're going to deal with areas, right? So it's quite, look at the mark allocation here, guys. In an advanced paper, out of 100%, what's that? 2, 4, what's that? Sorry, 8, 12 marks, right? That's more than, that's 12% of the test, one question. So if you couldn't do this, your marks are in jeopardy, right? So let's go through this bit of detail. Shouldn't be too long, nice short video. So here we go. Diagram shows a rectangular piece of paper with sides PQ is 6, I think that's given there, and PS is 12, great. Points M and N are selected and it's just folded into a nice triangle so that the paper folded the corner from which was at R becomes O, okay? So R becomes O, cool. MR is X, MN is L, right? And it also, and Y is upstairs, okay, cool. Copy or trace, show that OS, so part 1, OS, where's OS? Which one's it? This guy? Right, looks like Pythagoras. Show that by considering PQRS as a sum of the parts, show that Y equals that, okay? Area. Shouldn't max, show that, okay. Coincides, okay. Show another thing and then the maximum minimum question, 4 marks, wow, cool. Minimum possible length of L, okay. There's a lot to unpick there, right? Let's take this slowly, one by one. Let's do question 1, right? So question 1 says, ask you to show that OS, this side here, right? Which looks like it's got right angles there, right? Is that, now what do I know, guys? I know that, so when it's folded, let's see, this length here looks to be 6 minus X, right? Yeah, so 6 minus X. OS, I don't have it, but this side here, now, this side here was folded from here, right? So that must be X as well. Is that okay? Yeah, so maybe it's black there. That must be X as well. So then I have my enough information there to use Pythagoras. So OS squared is equal to the hypotenuse squared minus 6 minus X squared. Yeah, expanding that, X squared minus 9 minus 6X plus X squared. X squared goes away, so that becomes what, 9? No, that's Y. 6X minus 9. Yeah, and then therefore, now, what have I done there? 3 looks right, but there's a 2 there. Why is there a 2 there? I've done that wrong, haven't I? I've expanded that wrong. Oh God, guys, where's my touch? That guy there, that guy there. That's 12, and that's 36, which means this guy here, yeah, is 12x. No, yep, 12x. That's 36. So if I am, I'll take out the 4, right? Because that's what the question is telling me to do. Because I'm going to square root it. That becomes what? 3x minus. No, I'll do all of this. Let's take out 12. X minus 3, and therefore OS square. Oh, sorry, not squared. Square root is 2 root 3. Square root is exactly what I want. Yeah. So be careful about perfect squares. All right. Now, question 1 done. All right. Let's do question 2. That wasn't too bad. Looks like it was just Pythagoras. Now, question 2, by considering the area of PQRS and the sum of the parts, it looks like if I take the total area, right, the total outer area, that's made up of 4 parts, right? It's made up of trapezium, triangle, triangle, triangle. In fact, trapezium, triangle, and these two triangles are exactly the same, right? Because it's the same folded, right? So when I find that area of a triangle, I'm just going to double it, right? Is that okay? So 4 pieces of area. So area of PQRS. Firstly, it's a rectangle and it's got a height of 6 and a base of 12. So 6 times 12, was that 72? Yeah, 72. Let's see, what else do I have? So, and that comprises of, that's also equal to, it's also equal to the sum of the 4 parts, right? So it equals to, now, if you wanted to do, full sort of work and you go PQ, but I'll go trapezium. You know what? I always do this with my students. I just like to draw the shapes. Trapezium plus small triangle plus 2 of these bigger ones, right? Yeah, 2 of them because they're identical. So I'm just going to do it like that. Yeah, times 2. Is that okay? So trapezium, right? All right. So trapezium, I know it's going to be H on 2, so 6 on 2 times top minus bottom. Now, what's the expression for the top? So this side here is going to be, that's y and that's 12, so that must be 12 minus y. And this side here, this is 12, and the green is found. Wow, that's not pretty. Is that what they want me to do? Yeah, I guess so. Guys, this side is 12 minus OS, which is like 2 root 3 x minus 3. Great. Right, so I got that. Now, what about, I got x, got y. Okay, I can find that pretty easily, right? Got x, got y, that's pretty easy. And this one here got based on. Okay, cool. I can do stuff, right? I've got all the things I need. So this one here would be h on 2, top minus bottom. What was top? 6 minus, no, was it 12 minus y? 12 minus y plus 12 minus this monster. Okay, wow, just looks a bit algebraic. Maybe that's why it's 2 marks, right? All right, that is just the trapezium, all right, plus small triangle on the bottom. So that's just a half base times height. Okay, so base, which is 2 root 3 x minus 3 times height, which is 6 minus x. Just check that. Yep, perfect. Okay, maybe I'll zoom out. Yep. So this guy is this. This guy is this. And last but not least, these two, which just looks like x times y, right? Half times x and y times 2. So equal plus a half x, y, and then multiply by 2, right? That's the blue part. Perfect. Now, let me just check. Looks a bit messy. Now, what am I trying to do? I'm trying to make y the subject. Okay. So, and all this equals to 72, right? Because that's the total area, right? All right, let's clean this up. Now, I don't have any more space. Unless I do this, of course. Let's move it up. Okay, perfect. Okay, let's see, 72 equals 2. Now, that looks like 3, 24 minus y minus 2 root 3 x minus 3, right? And then plus half and 2 go away. Okay, so it's another, it's root 3 x minus 3, 6 minus x, and plus xy, right? Okay, I'm a bit afraid right now. There's a lot of y. Oh, okay, no, the answer has all this stuff as well. Let's expand everything. So 72, what's 3 times, is that 72? Tell me that's 72. That'd be nice, because then it comes, it's 3 times 24. Checking it? Yeah, beautiful, 72, good. Yeah, and then minus 3y, I'm just expanding everything, right? 6 times this, 3x minus 3 plus, oh, great. There's 6 of these guys as well, so they cancel out. Great, 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 great. Yeah, it's just like scary algebra. And minus x times this. Sorry, I'm running out of space. Just literally need to write x, y in. That's it. Yeah, so guys, things that cancel out. That guy's gone. That guy's gone. Great. So the only thing that's really left is now I'll bring this guy and this guy over the fence because they're the only terms that have y. So it becomes like 3y minus xy equals 2. What's left? No, I don't like how that's a minus. Is it really a minus? Oh, that's got, no. What am I doing? I think this is x minus 3, right? Let me just check that, guys. Make sure I'm on the right track. That guy's gone. That guy's gone. Now bring this over. Bring this over. Okay, yeah. All right, that's fine. There's a negative there. That's fine because I'm going to factorize and see if I divide it over the side. Hope it works. X minus 3. Factorize y out. You know what? I'm going to be smart. I'm going to factorize negative y out. All right, so that becomes x minus 3 minus x root. How does that look like it's going to work? So let's see. Yeah, I think it does. Guys, I don't want to. I'm just going to copy this, if that's okay. So cut it to the next page. I'll have it fresh, so it doesn't actually break up. Okay. So where are we going? This guy's gone. This guy's gone. I just need to divide it over, and I think I got it. Right? I think I got it. It doesn't really look the part right now, but check it out. You know what? Can I break up this third to root 3 times root x minus 3 over x minus 3? Because when I do this, right, are you guys okay? I'm going to go that guy divided by that guy and leaves root x minus 3, right? Because it's like root a divided by a, right? Which is, 1 over root a. So therefore, y equals 2. Wow, that was quite heavy algebra. Surprisingly heavy for part 2. Done. Yeah, that's what I want. Perfect. Yeah. Okay, I need more space. Wow, this is why it's 12 marks. It's just taking a lot of space. Come on now. Like that. Okay, let's zoom in. What's the next part? You may assume that the minimum value of x, so the smallest value of x, occurs when n collides with q. Okay, so when this guy goes to q, yep, the fold is the smallest. Okay, that makes sense. So basically, as you sort of get big, you get bigger when n goes towards r, but you get smaller for x when n goes towards q. Okay, show that. Okay. All right. Well, it just feels like we're going to use the part above, right? What's y? So y is that? So minimum value of x, okay, occurs when that equals to that. Okay. So I guess when y, so it's like this, right? Does it make sense that x basically, as this point here goes up, this point here goes here, right? Do you mean like as it sort of goes up? So as y equals to 12, as y approaches 12, x approaches 0, right? So that's what it's trying to say. The minimum value of x occurs when y goes to q or when y goes to 12. So why don't we sub 12? See this expression here? Why don't we sub 12 in and see if we can find a value for x, right? So for part 3, seems like y is approaching 12. Yeah. So I'm just going to sub it in today. Sub it in and see where it takes us. I'm hoping that it forms some sort of quadratic or something that I can find max min of. or something. Root x minus 3. So let's just try to solve for x, right? Maybe square both sides. 144 equals to x squared or 3x squared over x minus 3. Looks like we're ready. Times it up. 144 x minus 3, 3x squared. Maybe divide both sides by 3. What's 144 divided by 3? 42. 48. X minus 3. X squared. X squared minus 48x plus, well, times 3, 144. Equals 0. I don't think it could be factorized, so maybe complete the square. So x squared minus 48x equals to negative 144 plus, what's that? 24 squared to both sides. Yeah, and so you get like minus 24. Guys, what's 24 squared minus 144? 432. So you sort of get like x is equal to, let's see, so you get like 24 plus minus, now root. So what can go into that? 16 times 9. So it looks like 144, so 12 root. Simplify that third, right? 432 divided by 144, what do you get? Is it 3? 3, yeah, perfect. Yeah, now it's a value back. It looks very similar to this, right? So if x equals that, right? But, however, right, if you look at the value for x, right, x can't be negative, or it can't be small. So x can only be, you can see here, x has to be between 0 and 6, right? So what do I say, right? But x is bound between 0 and 6. So then the smallest value it can go, like it can't be bigger. So the smallest value it can go, right? If I just take the minus case, because I don't want the plus, right? I just want the minus, right? Because this sort of maximizes and minimizes it. I just want the minus case, right? Just want the minus case. So I'm just going to put a little highlight here, right? So take minus case only for min, right? And since x is between 0 and 6, the minus case is the smallest number. Therefore, 24 minus 12 root 3 is the smallest, 6 is the biggest, and x is bound between the two numbers. So let me say that again. Why did we do that calculation? Because x, sorry, let me move this back up. In this case, x minimizes when 12 goes, when y goes to 12, right? So we sub 12 in just to explore the value, just to find the value of x, which is the smallest, right? When y equals to 12, we got that x equals to 24 plus minus 12 root 3. The plus version is obviously the bigger one, and we don't want that. We want the smaller one. 24 minus 12 root 3, that's the lower bound, but we know that x can't be bigger than 6, so therefore x is bound between them. Yeah, is that okay? All right, let's keep going. Almost there. All right, next question. Let's delete that. Zoom in. It's a 1 marker, hopefully quick. Show that the crease is given by that. Now the crease looks like Pythagoras, right? Is it just Pythagoras? Looks like, and then I sub y in, I think, because yeah. Okay, cool. This should be quick. Part 4. L squared equals to x squared plus y squared. And of course, the question only wants it in terms of x. So I'm assuming that they want me to take this guy and plug it into here, right? So then I get equals to x squared plus x root 3 on root x minus 3 squared. What's that? So plus 3x squared over x minus 3. I think they common denominator because I think they got the x cubed in there somewhere. Yep. Okay, so it comes like x squared, x minus 3 plus 3x squared. 3x squared cancel out and you sort of get like x cubed over x minus 3. Yeah, therefore length was the square root of x cubed over x minus 3. Done. Yeah. Now for 4 marks minimum. So I need to, this is basically the game, right? We've worked through, was it 8 marks to get us to the optimization question, right? So let's start a fresh page for this, right? All right, so let's optimize. So I've got, so this is for part 5, L equals to square root of x cubed. My God, nice question, right? It all sort of leads to this one. All right, I've got to differentiate it, right, and test for max min. So dl dx, right, equals to bring down the half, yeah, minus 1 to the power, and then multiply by, now the derivative of the inside, I need to actually do some work, right? So if this was just the inside, this will be u, this will be v. I know that u dash is 3x squared. I know that v dash is 1. So then the derivative of the inside is a quotient rule. So it'll be u dash v, 3x squared times x minus 3, minus v dash u, so 1 times that, so it's x cubed, all over v squared. Right, that's a derivative. Let's clean it up a bit, because then I need to solve it. So half, you know what, no. So that's negative half, so I'm going to have to flip and square root, right? So half, flip and square root, and then multiply that by, I got, what do I have here, guys? I have x minus 3 on the bottom squared, 3x cubed, minus, no. Yes, 3x cubed, so I've got 2x cubed minus 9x squared. Yeah, nasty, right? Nasty. So once we get that, let's see, we're gonna now solve it, I guess. So let's go forward and set that to 0, right? Well, we're definitely not going to use the second derivative to test for max min, right? We're definitely going to use table method. So when I sub this equals 0, the 2 goes away, right? And let's see, because it's times. Now, what do I do? Okay, cool. I'm gonna start, should I start canceling things out? All the denominators go away, right? Is that right? Yeah, denominator goes away. So when this equals 0, let's see, actually, let's see. So when this equals 0, how do I solve it? Because technically speaking, right, if I was to clean this up, okay, let me clean it up first. 1, 2, see this guy? Are you guys okay once again to cancel this? Oops, sorry, wrong color. This guy out with like this guy and leaves a half. So it still looks like this, right? So it looks like, if you had to simplify this crazy expression, it sort of becomes 2x cubed minus 9x squared on top. Because that cancelled out, the only thing that's left is there's a 2 there, and there's a square root of x cubed multiplied by x minus 3. Yeah, that's basically as simplified as it can get, and that's what I'll use for testing max min. This guy then, when I solve it, sorry, this is my dl dx. I want to write that because I want to actually box it later on to know that that's what I'm going to use to test for max min. When I solve this, this guy goes away, great. So then the only thing that I'm left to solve is if I take out x squared from the top, it'll be 2x minus 9 equals 0. And then x equals to 0 and 9 on 2. Right, can't be 0, right? So I'm going to test for max min for this guy using the table method. So using this, right, test for max min, right? So then table, I've got x over here, I've got dl dx over here, I've got 4.5 in the middle, maybe 5 and 4. There's no other stationary points around. That guy's definitely 0. So on your calculator, I think -1. and 0.395. Surprise, surprise, it's a minimum, right? So therefore, min L occurs when, now what am I asking actually? Justifying, yes. Find the minimum L, right? When x equals 9/2. And so therefore min L equals 2. I basically subbing 4.5 in, right? Should get approximately 7.8 centimeters if you do the mathematics and sub it in. Wow, what a question, right? I like it. Nice. It's a nice one because there's so many parts and it leads you down to the final part, which is actually quite hard in itself to differentiate and solve. But that's how you do it. Guys, hopefully that was a good video. Subscribe to the channel, like the video, and I'll see you at the next one. Thank you very much.